You ever stop and think about what's happening inside your phone or your laptop to keep the power running so smoothly? Well, there's this unsung hero, this tiny component, working away in almost every piece of electronics you own. So today, let's pull back the curtain and get to know the inductor.
Right, so think about this. Electricity isn't always a nice, calm river. It can spike, it can drop, it can get messy. And all that chaos would absolutely fry our sensitive gadgets. So what's standing in the way? What's the bouncer at the club door that keeps that electrical current in line?
Well, here it is. This is the inductor. I know, it might not look like much, basically just a coil of wire, but trust me, its job is one of the most important in all of electronics. This is the little guy that tames those wild currents, making sure everything works the way it's supposed to.
So, let's get into it. What exactly is this gatekeeper of current? And how does it pull off such a critical task?
Okay, so at its very heart, an inductor is a passive component. That just means it doesn't create its own power. It just manages the power that's already there. When you pass a current through that coil of wire, it builds up energy, but not as electricity. It stores it in a magnetic field. And that magnetic field, well, that's where the magic really happens.
I love this analogy. You know how a big, heavy flywheel in a machine is really hard to get spinning, but once it's going, it's just as hard to stop? An inductor does that exact same thing, but for electricity. It hates change. It resists any attempt to speed up or slow down the flow of current.
So how on earth does a simple coil of wire get this kind of superpower? To figure that out, we've got to look a little closer at what's going on inside that magnetic coil. The design is actually beautiful in its simplicity. You just take a wire, usually copper, and you wrap it around some kind of central core. And really, that's it. The material you used for the core and how many times you wrap the wire around it, that's what determines just how strong the inductor's effect is going to be.
Here's the secret sauce, broken down into 4 steps. 1. You send current through the coil. 2. A magnetic field instantly pops up around it. 3. That field starts storing energy. And now for the big finale, step 4. That very same magnetic field will now actively fight back against any change to the current that created it. It wants to keep things stable.
And this amazing property, this resistance to change, it has a name. We call it inductance. We measure it in a unit called the Henry. So to put it simply, the higher the Henry value, the more that inductor says nope to any change in the current.
Okay, so we've covered the what and the how. But the really big question is, why? Why is this electrical flywheel so darn useful? Well, in the world of electronics, an inductor basically has 2 huge jobs. Job number 1 is all about filtering. So you have alternating current, or AC, which is constantly changing direction, right? An inductor sees that and puts up a huge fight. Engineers call this impedance. It basically chokes it off. But steady, direct current, DC, that flows in one direction, the inductor lets that cruise on by. No problem. This makes it perfect for cleaning up electrical noise from a signal.
And its second job is storing energy. Remember that magnetic field? It's like a little energy reservoir. Now, you don't need to memorize this formula, but it just shows that the energy stored depends on the inductance, that's L, and the current. So, by soaking up energy when the current tries to spike and releasing it when it tries to dip, the inductor acts just like a shock absorber for your car, smoothing out all the bumps for a clean, stable power supply.
But of course, not all inductors are created equal. Just like with anything else, you've got different types for different jobs. And you can even combine them in different ways to get exactly the results you need. So, let's take a quick look at the inductor family tree.
The core material is a total game changer. Iron cores, super powerful, but they're not great at high frequencies. Air cores, which have, well, nothing in the middle, are awesome for high frequency stuff. Ferrite cores are kind of the best of both worlds. And you'll hear the word choke a lot. That's not a different type, it's just a nickname for any inductor that's being used specifically to block or choke out those AC signals.
So what happens when you hook them up together? Well, if you connect them end-to-end in what's called a series circuit, the math is super simple. Their values just add up. It's an easy way to get a bigger total inductance. But if you connect them in parallel, something really interesting happens. Now the current has multiple paths it can take. It's like opening up more checkout lanes at the grocery store. The total resistance to the flow actually goes down. Because of this, the total inductance ends up being even less than the smallest single inductor in the group. It's a clever trick for when you need to fine-tune a circuit.
You know, to really understand what makes an inductor so special, you've got to meet its famous cousin, the capacitor. They both store energy, but but they are polar opposites in almost every single way. It's a classic tale of two components.
And this table just lays it all out perfectly. Look at this beautiful symmetry. An inductor fights changes in current using a magnetic field. A capacitor fights changes in voltage using an electric field. They are the yin and yang of a circuit, which is exactly why engineers use them together all the time to shape and control electricity with incredible precision. So, the next time you power on your phone or your computer, just take a second to remember the humble inductor. This simple coil, this flywheel for electricity, is a true pillar of modern technology, silently making sure everything just works. It kind of makes you wonder, doesn't it? What other amazing secrets are hidden away inside the circuits all around us?